Okay, so we're going to start on some of these problems in section 3. And if you read the 2 paragraphs before the first problem, you'll see that these were actually from some mathematics teacher calendar. And so my opinion is they really are a little bit too detailed for you guys at this point. Surprising, this is the 3rd section of the 1st chapter. They are some of them can be quite difficult to think through. So that's why I'm recording the solutions, so you can at least get an idea of what the thought process is. And to be completely honest, when I first did this, the problem number 1 I got correct, but I didn't like their explanation in the solution manual, which gave me a little concern. Then I did the 2nd problem, and I just didn't read it correctly. So even I don't read problems correctly. You got to really be careful about what they're asking for in these problems. So we're going to do the first. We're going to do 4 problems: 1, 5, 9, and 13. At least in this video. So problem number 1 says a classroom contains an equal number of boys and girls, and if 8 girls leave, then twice as many boys as girls remain. What was the original number of students present? So the way I approach this problem is I decided that I would assign a variable to the number of girls initially in the class and the variable b to the number of boys initially in the class. And then try to use the description of the problem to come up with an equation that I could solve. So what the problem says is that initially they're the same number of boys and girls, equal numbers. So b is equal to g. And we know they're asking for the total number of students present. So that's going to be total number of students initially present is going to be b plus g. This is what we're going to be asked to find finally, but we need to find out what b and g are. And then I'm introducing this other variable b prime. This is like a 1, but it's more like not an apostrophe, but it's just a markup here. And that's to show it's not the original b, but it's some b later on. So b prime is the number of boys after we have this change. The change is the 8 girls leave. G prime is the number of girls after the change. So that's b prime and g prime. So the problem says that we don't have any boys leave, so b prime is equal to b. And we have, when the girls leave, the number of girls left is equal to the initial number of girls minus 8. And then finally, the comment about there being twice as many boys after they leave, after the girls leave, you can say that b prime is equal to 2g prime. Twice, if you take the number of girls and you multiply it by 2, you get the number of boys. Okay, then we just do some substitutions. We know b prime is b, and we know g prime is g minus 8. So you plug those in. And when solving problems, especially when you put it in a mathematical form, and you have unknowns, if you have one unknown and one equation, you can solve for it. It's just a matter of doing the algebra or whatever operations that are required. If you have 2 unknowns, then you have to have another equation. So we have one equation here and 2 unknowns. So I need another equation. And another equation we have is that initially the number of boys and girls are equal to each other. So we can use that. So we could either substitute in for b, we could put in g, or for g, we could put in b. It doesn't matter which. Just depends on which one we want to solve for first. So in this case, I change b to g because we have an equivalency. Okay, so we get g is equal to 2 times quantity g minus 8, and you multiply this out, which is called the distributive property. So you multiply the 2 times g and 2 times the negative 8, and you get 2g minus 16. And then to solve for g, we add 16 to both sides of the equation. We subtract g from both sides of the equation. What that does is it makes this negative 16 go to 0 when we add the 16, and we add 16 to the left-hand side, so we get plus 16. And then we subtract g, that makes this go to 0, and this go to g. And so doing those two operations to both sides of the equation, you get g is equal to 16, or 16 is equal to g, or g is equal to 16. And so the number of girls initially is 16, and because the number of boys and girls are initially the same, b is also equal to 16. And so the total number of students, as you add these two together, and you get the total number of students is 32. 16 girls and 16 boys. And you can see in the original problem, if you started with 16 girls and you subtracted 8, you'd have 8 girls, which is half of the number of boys. So boys twice as number, so twice as many. So that all works out right. So the answer in this case is 32 total students. 16 boys and 16 girls. Okay, number 5. The schools in an athletic conference compete in a cross-country meet to which each school represents or sends 3 participants. Aaron, Caitlin, and Ileana are the 3 representatives from one school. So what can we say about that? Well, we know the number of participants, let's use P for number of participants, is just going to be 3 times X. Okay, so this is P is equal to number of participants. And X is equal to number of schools, because we have 3 participants per school. Now, Aaron, in this case, is one particular school. Aaron finished the race in the middle position. That means the middle of all the schools. And what does that tell us? Well, if you had, let's say you had 4 teams. So let's just pick X so as example. X equals 4. Then P would have to be equal to 12. We'd have 12 participants. And so if you took the middle person there, and let's just put this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we mark off the beginning and end, and we keep doing that, beginning, end, beginning, end, beginning, end, we end up with 2 people in the middle, not just 1 person. So now let's say we had 5 schools, and we'd have 15 participants. Let's actually use 3 schools, so it's easier to deal with in terms of the numbers. But let's let X equal 3 schools, participants equals 9, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So to get to the middle, you cross off the ends in pairs, and you end up with 1. So basically what Aaron being in the middle means that, for one thing, that the number of schools has to be an odd number. Okay. Now, if we go to the next part, Caitlin finishes after Aaron in 19th position. So let's say Caitlin, we're going to say this is their position, so 19th, and Ileana finishes 28th. Well, we know we have to have at least 28 teams. And we also have to have the number of participants has to be divisible by 3. So what options do we have? What's 28 divided by 3? It's actually 28 divided by 3 is 27, is 9 times 3 times 9 is 27, so it's going to be 9.33. Okay, so we have to have at least 19, more than 19. So we have 10 teams, 11 teams, 12 teams, 13 teams. So those are options. We have to have at least 10 teams, so we have at least 30 people. And it can't be 10 teams or 11 teams, 12 teams, because if that's the case, then we don't have a middle participant. So these are this is X, possibilities for X. And so the possibilities for participants are 33 or 39. You could add, you could go back here, you could have 14, 15, and you'd cross 14 out, so they don't 45 participants. Now, if there's 33 participants, what's the middle? So let's say middle, question mark, participants are 33. Well, it's going to be take this divided by 2, actually 34 divided by 2 is 17. So the middle position would be 17. If the middle, what's the middle if we have 39 participants? Well, the middle would be equal to 20. Well, it says here that Aaron finished the middle of the race, and Caitlin finished after Aaron. So Caitlin if Caitlin is 19th, Aaron can't be the middle here because she'd be 20, so that doesn't match up the requirements. So it looks like this is the only choice that fits all the requirements. So the middle would be 17th. So Aaron would be 17th. What was the next person's name? Caitlin would be 19th. And Eliana would be 28th. And that would be the... So in this case, the total number of teams is 11. Total number of participants is 32. So the middle person is 17. 17 is Aaron, which is before Caitlin. If we had used this, Aaron would be 20th, Caitlin would be 19th. And therefore, Caitlin would not finish after Aaron. Aaron would finish after Caitlin. So the final answer in this particular case is, what's the question? The question is how many teams, which is 11. So we're kind of using a little bit of, using each little piece of information to eliminate possibilities. So we're not actually solving a particular equation. We're kind of working through the possibilities. Okay, number 9. A 26-volume encyclopedia, one for each letter, is placed on a bookshelf in alphabetical order from left to right. Each volume is 2 inches thick, including the front and back covers. Each cover is 1/4 inch thick. A bookworm eats straight through the encyclopedia, beginning inside the front cover of volume A and ending after eating through the back cover of volume C. How many inches of the book did the bookworm eat? And your first tendency is to think, okay, here's my front cover, and here's my back cover, and here's my pages. And so I start on the inside of the front cover, and I eat through all these books, and I come out the back cover of the last book. So this is A, and this is C. And so you'd say, okay, well, each one's 2 inches thick, 2 inches thick. There are 13 books, but we don't have to go through the front cover, which is 1/4. And so you'd have 2 times 26 minus 1/4. And so you think, oh, okay, that's 52 minus 1/4, it'd be 51 3/4. And that would be wrong. And you'd say, I don't get it. And the tricky part here is when you take a book, the inside cover is on this side. But when you turn the book and put it in the bookshelf, your inside cover now, instead of being here, starts right there. So what you'll do is you'll go through all these letters. Here's A. Here's all the other letters, which will be 26 minus 2, which is 14. So we get 14 times 2 inches. And then we have Z, and it says we go through the back cover. Well, the back cover is here when we're thinking in this way, which is wrong. But when we turn it around, the back cover is actually right here. So we have a 1/4 inch to go through this cover, and we have a 1/4 inch to go through that cover. And so the total distance the bookworm travels is going to be 2 times 1/4 plus 2 from the number of volumes, A and Z, 1/4 inch for the covers, plus 2, which is 2 inches, times the number of volumes, which is 14. And so we should get, why did they keep 14? 24. 24. So 24 times 2 is 48. 2 times 1/4 is 1/2, so you get 48 and 1/2 inches as your answer. Okay, and number 13, we have the gasoline gauge in a van initially reads 1/8 full. When 15 gallons is added to the tank, the gauge reads 3/4 full. How many more gallons are needed to fill the tank? So what we do is we start with 1/8 full. 1/8 times the number of gallons for a full tank. And then we add 15 gallons. And that results in the tank being 3/4 times the number of volume per a full tank. Okay, so the easiest thing to do is actually multiply everything by 8. The reason we do that is to get rid of these fractions. So 8 times 1/8 is 1, so we get F, just 1F, plus 15 times 8 is equal to 8 times 3/4 is 6. 8 times 3 is 24. 24 divided by 4 is 6. So we get times 6F. So we subtract F from both sides. And that makes that go to 0. And this becomes 5F. And then we have 15 times 9, which is going to be 120. How did I do that? Well, 8 times 10 is 80. 8 times 5 is 40. 80 plus 40 is 120. And then you take 120 divided by 5, and we get 24. So a full tank is 24 gallons. And the question was, how many more gallons are needed to fill the tank? So if this is 3/4 of a tank, we need another 1/4 of a tank to get it full. So to fill the tank, we have to add another 1/4 of a tank. So we have 1/4 times 24, which is 6 gallons. So this is actually more and more where you can actually come up with an equation and just do it. Some of these others here require us kind of drawing a figure. We really don't have to draw a figure here, but drawing a figure and then mentally making sure we did the problem correctly.